Here I'll briefly describe statistical disclosure attacks for mixed networks. And here's a basic architecture diagram. Clients retrieve a network view from some kind of PKI system, and then they can send and receive messages from the mixes. And so we can abstract away all these details and just make the entire mixed network a single mix. Because basically messages come in and messages go out. So this abstraction allows us to think about it such that, say, for example, OS1 is communicating with some of these Bobs over here. If she goes offline, then and the adversary notices that Bob 1 and 2 receive 5% fewer messages, then that is some statistical information that's leaked. And since we can't prevent users from going offline, this is sort of the horizon at which mixed nets can't cross. We can't do better than that in a sense. However, this doesn't mean it applies to all the applications of mixed networks. And this also doesn't mean that statistical disclosure attacks always converge on success. It depends a lot on how repetitive and predictable user behavior is. And so this is the expanded view of the previous diagram. And implicit in this diagram is that there is some sort of NAT penetration protocol being used, like NAT stun, turn, ISPMP, and so on, because this egress mix here on the right is communicating directly with clients. And clients these days on the internet are using routers with NAT devices. And so this network address translation prevents communication directly to clients behind these routers unless they engage in one of these complex protocols. And so if we want to avoid that, we can use providers to queue messages. And even if avoiding that complexity isn't really our main goal, there still is some advantages to using this architecture. So our clients are sending messages through the mixes, and they're getting queued on one of these providers. And these providers could have 10,000 users or a million users. And so this vertical line on the right represents the area of the network that the adversary wants to watch. Well, these two vertical lines are both areas of the network they want to watch. And the one on the right, is leaking a very little information in terms of who the message is being sent to. All the adversary knows is it's being sent to one of it can see which provider it's being sent to, but it doesn't know which user on that provider. Without collusion with that provider or compromising that provider, from a passive adversary's point of view, it's a lot less metadata. And this is one of the cool designs that we get from the Loopix paper. And in the description of this video, I'll post a link to Ania's Usenix talk describing the Loopix anonymity system, and I'll also post a link to her paper. And so Katzenpost mixed network is very much inspired by Loopix. And here I'm going to describe now the decoy traffic loops that clients send. And before I delve into the details, it's important to note that clients make use of a FIFO queue for sending messages into the mixed network. So that is to say, users don't get to send messages whenever they want. Users choose to send a message, and then in their client, it'll be queued in this FIFO queue. And the client selects random times from an exponential distribution. This is a Poisson process described in the Loopix paper, where the these random time intervals are selected to pull a message out of the FIFO queue and send it into the mixed network. Now, if the FIFO queue is empty, then instead of sending a forward message to some other user on the mixed network or to engage in some sort of application on the mixed network, the client will then send itself a decoy loop. And these decoy loop messages serve two purposes. One is it prevents an adversary from determining when a client is sending a legitimate message or when they're sending a loop message. The other thing it helps with is if Alice's provider is compromised, then the adversary compromising the provider won't know when she's receiving a message or receiving a loop decoy message. And so the way this works is Alice selects some random provider, and the message, so this route terminates on the random provider, But in the forward message, she bundles a single-use reply block. It's a special feature of the Sphinx cryptographic packet format and allows for anonymous replies. So that provider then sends the message through the mixed network once more, and then it terminates on Alice's provider. And so this is essentially indistinguishable from all the other traffic on the Katzenpost mixed network. All application usage on the mixed network looks exactly like this. Whether Alice is sending a message to Bob or in some sort of chat or messaging application, or whether so Alice could send a Zcash transaction to the blockchain, and so this terminating provider here could submit the transaction on her behalf, and then send an acknowledgement message back to Alice. And you might be thinking, well, why send an acknowledgement back to Alice using the mixed network when Alice can just go look on the blockchain and check to see if her transaction is there? That's a broadcast mechanism that would hide her identity when she's checking that, right? So the reason is because we want for example, Zcash cryptocurrency transactions on the Mix network to be indistinguishable from all the other applications on the Mix network. And these different applications being used on the Mix network would provide cover traffic for each other. So there could be chat and messaging applications, high or low latency and so on, and also Zcash and Bitcoin and so on, other types of cryptocurrency transactions. Additionally, when you do retrieve a message, so in this diagram, Alice connecting directly to her provider to retrieve messages, she we're using a traffic padded protocol, and this is another cool design from the Loopix paper. So in this case, when clients send a message retrieve command, the traffic padding essentially here means that they retrieve the same amount of information no matter how many messages they have to retrieve, even if they have no messages. That's it for now. Please feel free to contact me if you have any questions.